Good morning, this is Kavi Priya, Assistant Professor, EC Department. I am going to discuss about the topic Ohm's Law from the subject Circuit Analysis and Devices. So first, let's see what is a electric circuit. Electric circuit is a interconnection of various elements in which there is at least one closed path in which current can flow. Electric circuits consist of two type of elements. They are active elements or sources, passive elements or sinks. Active elements is nothing but it is an element of a circuit which possesses energy of their own and can impart it to other elements of the circuit. There are two types of active elements. They are voltage source and current source. So the current is a rate at which electric charge flows past a point in a circuit. In other words, current is a rate of flow of electric charge. Voltage is also called as electromotive force. It is a potential difference in a charge between two points in an electric field. And a current source is an electronic circuit that delivers or absorbs an electric current which is independent of a voltage across it. A current source is a dual of voltage source. A voltage source is a two-terminal device which can maintain a fixed voltage. Passive elements is nothing but it is an element of a circuit which does not possess energy of their own. The passive elements are the resistance, inductance and capacitance. Resistance is a property of a conductor by virtue of which it opposes or limits the flow of current through it. The unit of resistance is ohm. And resistance is a circuit element that dissipates electrical energy. Real world devices that are modeled by resistors are incandescent light bulbs, heating elements, long wires. Resistance is measured in ohms. The cell stores a chemical energy and transfers it to electrical energy when a circuit is connected. When two or more cells are connected together, we call it as a battery. The cell's chemical energy is used up pushing a current around it. In which direction a current flows from a negative terminal to a positive terminal of a cell. And next is it is a simple electric circuit. It has a cell, it has a lamp and it has a switch. When a switch is closed, a lamp lights up. This is because there is a continuous path of metal for electric current to flow around. If there were any breaks in the circuit, the current could not flow. And this is a scientists usually draw electric current using the symbols. And these are the symbols of cell, lamp, switch and wires. So in a circuit diagram, components are represented by following symbols. It is cell, battery, switch, lamp, buzzer, meter, voltmeter, motor, resistor and variable symbols. And next is Ohm's law. A German physicist called George Simon Ohm, who published a pamphlet in the year 1827 that described the measure of current and voltages and to describe and relate them mathematically. One result was a statement of a fundamental relationship. We now call it as an Ohm's law. Ohm's law states that the voltage across any conducting material is directly proportional to the current flowing through a material. V is equal to Ri, where V is a voltage and I is a current and R is a constant of proportionality called as a resistance. So V of t is equal to I of t into R or V is equal to IR. The temperature remains constant. Only when the temperature remains constant, the Ohm's law holds good. So when the temperature remains constant, the current flowing through a conductor is directly proportional to the potential difference between the two ends of the conductor. I is proportional to V only when the temperature is constant. So to remove the proportionality, a constant R is used where R is a constant of proportionality resistance. So I is equal to V by R. R is the resistance of the conductor. Ohm's law can be applied for both AC and the DC circuits. And there are certain limitations for Ohm's law. Ohm's law holds good only for a metallic conductor. For non-metallic conductors such as silicon carbide, this Ohm's law does not hold good. And also the Ohm's law is applicable only when the temperature remains constant. When there is a change in the temperature, this Ohm's law does not hold good. It is not applicable. And also Ohm's law does not hold good for nonlinear devices such as Zener diodes, voltage regulators, etc. It is applicable only for the linear devices such as resistor, inductor, capacitor. And next is a resistance. The unit of resistance is ohm, which is 1 V by A and customarily abbreviated by a capital omega. Resistance is normally considered to be positive quantity, although negative resistance may be simulated with a special circuitry. And next is a power absorption. The product of V and I gives a power absorbed by the resistor. V and I are selected to satisfy the passive sign convention. The absorbed power appears physically as heat or light and is always positive. A positive resistor is a passive element that cannot deliver power or store energy. Alternate expressions for absorbed power are P is equal to VI, which is nothing but I square R or V square by R. So that's all about the basic components and about the Ohm's law and what are all the limitations of Ohm's law. Thank you.